In this unit, we study about fluid dynamics. Fluid dynamics has two parts, fluid mechanics and fluid statistics. Fluid mechanics studies laws of equilibrium and motion of fluids, and fluid statistics deals with equilibrium of fluids and their stationary interactions with solid bodies. For this, let us first define what is fluid.
Pause this video
You
and just
all
write
must have
what
studied
is
about
a
the
fluid.
definition of fluid in the previous classes. According to these studies, we define fluid as a substance that can flow and does not have shape of its own. Example, gases and liquids. Therefore, liquid does not have any shear elasticity and it cannot withstand shear stress. This gives rise to the concept of pressure in liquids and the applications of Pascal's law, which we utilize in different new phenomena. Properties of liquid in equilibrium. Let us observe the properties of liquid in equilibrium. For this, let us have a look on this video. In this video, we have taken a round bottom flask, filled it with a liquid, and a piston is attached to its neck. If we make holes around the sides of this round bottom flask, we will see that water comes out through the holes when the piston is pushed down. From this, we can easily see that the liquid exerts pressure on the sides of the vessel to stop the outflowing liquid through all the points. Thus, the force acting at the sides of the vessel is called the thrust of the liquid. The direction of force acting on a surface containing liquid. For this, let us consider a hose pipe which is used for watering the streets. Let us have a hose pipe in which water is flowing through it. If we make a hole on the curved surface of the pipe, we will observe that the water rises vertically upwards, or we can say at right angles to the surface of the pipe. From this, we conclude that the force is acting always perpendicular to the surface of the container in which the liquid is present. This we can explain with help of the components of forces. If we consider a surface F pi, then at a point O, F is the force acting and its direction is shown as in the figure. From this, we have two forces acting at point P, a normal force F and a tangential force F2. Now, as there can be no tangential component, only normal component is present. Therefore, the total force is due to this normal component. Thus, we can say that force is perpendicular to the surface of the container in which the liquid is present. Liquid pressure. The pressure of the liquid at rest on any surface is the thrust exerted by the liquid on unit area of that surface. Now, this liquid pressure can be of three types: uniform pressure, average pressure, and a pressure at a point. Uniform pressure. Now, let us see what is uniform pressure. Pressure is said to be uniform when the thrust on any two equal areas of the surface is equal, and it is given by pressure is equal to thrust upon area. Average pressure. If the pressure varies in the vessel from point to point, then the average pressure is given by the total force upon the total area. And pressure at a point is given by the following expression in which we take into account the small force acting at small area. The pressure in a liquid is not same at all points. Thus pressure at a specific point delta F with specific force delta F with area small area delta A is given by P is equal to limit del T tending to 0 delta F upon delta E, or we can say dF upon dA. So the pressure at a point is given by dF upon dA. Unit and dimension of pressure. The unit of pressure is given by Pascal. 1 Pascal is equal to 1 Newton per meter square. The dimension of pressure is m L minus 1 T minus 2. From the formula of pressure, we have pressure is a scalar quantity as delta F is vector and delta A is a pseudo vector with the direction normal to the surface. Force is a direction, but pressure does not. Pressure at a point in a liquid at rest is same in all directions. That is, at any point in a liquid, pressure can act in any direction. Hydrostatic pressure. Let us now see an expression for a pressure at a depth in a liquid at rest under gravity. The pressure inside a volume of a liquid depends upon the depth below the surface, because the deeper we descend, the greater is the weight of the overlying liquid. In order to find out the pressure at point Y, distance h from the free surface of the liquid, let us imagine a vertical cylinder xy of height h around y. As you can see in the figure, a vessel has liquid in it, and we have considered a small cylinder xy inside that liquid. The height of this imaginary cylinder is h, and A is the cross-sectional area of the cylinder xy. From the figure, as you can see, we have volume of the cylinder is equal to A multiplied by h, where A is the area and h is the height of the imaginary cylinder. Mass of the cylinder we can get by multiplying the volume into the density. So the mass of the cylinder is equal to